Hi class. So we've been talking about humidity and saturation, looking at dew point temperatures and all that good stuff. Um, Now on a related note, let's take a look at what happens in the atmosphere when a bubble, or what we call a parcel of air, ascends and descends. Okay, so let's start off at the surface. And so we've got a little bubble of air, or a balloon of air, if you want to think of it that way. We call it a parcel of air in meteorological terms. And let's put in 10 air molecules in this bubble. Those will come in later to explain a process that's going on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, there's our 10 air molecules in our parcel of air. Okay, and for whatever reason, and we're going to talk about 4 different reasons why air would ascend or rise. We're going to talk about those later in this chapter. But let's get this air to rise or ascend. Okay, and once we get this air to ascend, we get this parcel to ascend, a whole domino effect or a chain reaction takes place. Okay, so the first step is that we get the air to ascend. So the air ascends, and when the air ascends, okay, now remember pressure, our column of air, okay, filled with those air molecules, and the definition of pressure was the force exerted by the weight of all of the air molecules above you. So as we move this parcel of air higher up in the atmosphere, there's fewer air molecules above it, so there's going to be less pressure on it. And as a result, when the air ascends, the air pressure is going to decrease. Okay, as you go up into the atmosphere, the pressure decreases. Okay, when the pressure decreases, that means that, okay, so right now we've got air pressure pushing down on this air parcel. When we get that air parcel to rise, the pressure is going to decrease. So with less pressure on it, it's going to allow this bubble or this parcel to expand. Okay, and so our parcel is going to expand. Okay, so once the air ascends, the pressure decreases and the air expands. Okay, now remember we still have 10, or hypothetical 10 molecules of air in here. So 1, 4, 5, 6, 7, 8, 9, 10. So notice the spacing of the air molecules, okay? So when our air parcel holding 10 molecules here goes up into the atmosphere, the air ascends, the pressure decreases, the air expands. Notice that the density of the air molecules decreases as it goes up. So when the air expands, the density decreases. Okay. And when the density decreases, that is going to cause the air temperature to decrease. So the temperature decreases. Okay. So as we've taken our air parcel, and this is a set of dominoes, all of these things take place. One thing causes the next thing to happen. So when we get this air to rise or ascend, the air ascends, the pressure decreases, the air expands. Because the air expands, the density decreases. Because the density decreases, the temperature is going to decrease. Okay, so if we remember back to our relative humidity, okay, that relative humidity is equal to the mixing ratio divided by the saturation mixing ratio. Saturation mixing ratio is temperature dependent, okay? So if the temperature is decreasing, that means that the saturation mixing ratio is decreasing. And if your denominator decreases, that means your relative humidity is going to increase. So we can add a couple of more steps here. So when temperature decreases, the saturation mixing ratio decreases. And when the saturation mixing ratio decreases, the relative humidity is going to increase as the air ascends. Okay? And maybe this air keeps going. And so if we keep going up into the atmosphere, um, all those steps are going to take place again. The air ascends. Because the air is ascending, there are less air molecules above you, so the pressure is decreasing. Okay, if the pressure is decreasing, then our parcel is expanding, so we make an even bigger parcel with our 10 molecules of air in here. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when the pressure decreases, the air expands. When the air expands, then the air molecules are even further apart, so the density decreases. When the density decreases, then the temperature is going to decrease. Okay, and when the temperature decreases, the saturation mixing ratio is going to decrease. And that should cause an increase in relative humidity. Okay. And again, if it keeps going up in the atmosphere, same thing. Air ascends, pressure decreases, air expands, density decreases, and temperature decreases. Okay. So here is a set of dominoes, if you want, a chain reaction that takes place when the air starts to move up into the atmosphere. All right, so these are things that you should be thinking about. You should think about the logical nature of what's happening here. You can memorize it if you want to, but think about it in terms of logic too. There's a whole logical process taking place here. Okay, now whatever goes up must come back down, and so that's going to be the next thing that we talk about.